transistors on a semiconductor would double, right? And at this point in time, they're putting 7.4 billion transistors on a semiconductor. In my lifetime alone, and I think I'm one of the older people in the room, it's a very young conference, which I like to see, the number of transistors has grown by more than 8 million times, right? And that's hard enough to imagine, but you can actually look at this chart, and I failed to represent the chart correctly. This is years, and this is number of transistors on the left-hand axis, and it's not in a linear scale, it's on an exponential scale. That's what allows this to look like a linear line. And if you just project this thing out, by the year 2025, a run-of-the-mill $1,000 computer is going to have the processing power of the human brain. And by the year 2040, all the computers in the world will have more power than all of the brains in humanity. It's just amazing. We can't even understand the way our brains work linearly, what that's going to enable for us, right? But the key is, with all this power, you have to match it with software. And when you bring the world into the digital domain and use software, that's when you can really leverage Moore's Law, and as a technology entrepreneur, make amazing things happen. So there's great examples of where people have done this. There's also some massive failures out there where people haven't followed this. So let's start with a failure. I think the room is old enough to remember back in the day when a Nokia phone was the it phone. It was the status symbol, it was the phone to have. How many people had a Nokia phone at some point? All right. How many people have a Nokia phone right now? None of us, right? In fact, Nokia doesn't make phones anymore. I was searching, I was Googling, and I saw that Nokia might make a cell phone again for Microsoft by the end of this year. But needless to say, you can see who won. Apple with their iOS, Google with Android, right? And did they beat them with a better phone? From a hardware perspective, not really, right? But from a software perspective, absolutely, right? And they did that by leveraging Moore's Law with an open, software-centric platform that also enabled an ecosystem of app developers and truly unstoppable forces that are up in video device to watch videos with their kids. They do it on their phone these days. Uber is doing the same thing. They're upending, they're revolutionizing the taxi business. In fact, some say that one day it will be unthinkable to even own a car because Uber will be so successful. They're doing that with an open mobile technology platform that connects drivers and users to do that. Then there's Google. Google's an example of many things, but they used to be a search engine company. They're now leveraging a cloud-based platform, a wealth of data to help them create driverless vehicles. It's just amazing. So all of these are examples of companies using creating software-centric platforms and enabling massive ecosystems that use those platforms to drive incredible value and really start competing in really non-traditional ways, right? So the platform, what it does is it reduces the barrier to entry. And I'm going to talk about many examples where platforms reduce that barrier to entry over time, right? And then the ecosystem, what it does is it really changes the dynamic between the customer and the supplier so that they can do truly, really unique things moving forward. And it's really that collaboration that the ecosystem creates between customer and user that's been the unstoppable force that has toppled many industries moving forward. So you as a technology entrepreneur have got to figure out which side of these forces of platforms and ecosystems you're going to be on. So I've already used platform a ton. It was in the title of my paper. You've probably seen books or articles about the power of platforms, and you're going, and you should be, a little bit skeptical at this point, right? And to be honest, platform is an overused term, right? In fact, the term platform in 2010 was nominated the most overused tech term of the year. Every new company, new startup claims they have a platform. Every technology invest that I see in my company, people claim it's a platform. Established players, including myself, claim that they have a platform, right? But I'm here to clarify some things today. Real platforms, platforms that matter, they do exist. There's many examples. Amazon has a platform that we use every day for shopping. Apple has a platform I've already talked about. National Instruments has a platform, but that doesn't happen just because I label it a platform. To be a platform that matters, a platform that delivers real value, it has to be continually adapting and giving you the ability to leverage this Moore's Law exponential progress that we're seeing. It has to have an open and vibrant ecosystem that builds upon its capability and amplifies its impact. And ultimately, it has to deliver massive value to our customers in order for it to be successful and sustain itself, right? Nope, I was supposed to build through all these. Sorry about that. Don't know my own slides. So let me give you an example of a platform-based company that's near and dear to my heart. It's my own company. It's National Instruments. I've worked there for 26 years. Our mission is to equip engineers and scientists with the tools and really to equip them with a platform that accelerates their innovation, their productivity, and their discovery, right? And I'm talking about all engineers. We don't service one particular market or set of engineers. We have an audacious goal of enabling all engineers and scientists, particularly in the realm that deals with real-world signals, real-world analog signals of measurement, control, in developing embedded systems. That's where we really play and have a lot of strength. And we are disrupting those industries with a platform-based approach that changed the dynamic from vendor-defined solutions and systems to user-defined custom systems. And it's amazing what we do. So we do that with a platform-based approach that I've already talked about. At the center of our platform, and I've talked about this a lot, is software. Software is the key. In our world, we have innovated a tool called LabVIEW. It's a graphical programming language meant for engineers. Engineers typically draw diagrams on whiteboards to describe their systems. With LabVIEW, you draw those systems and it creates the program for you, right? How many of you have used LabVIEW? Maybe not many. How many of your kids have used Lego Mindstorms? Have you seen Lego Mindstorms? Well, then you've used LabVIEW. LabVIEW powers that tool. So kids in kindergarten are using our product. Rocket scientists that are launching things into outer space are using our products to do that. And then we leverage the semiconductors that are being driven by Moore's Law with an open modular hardware approach with different form factors, very rugged for industrial applications, high performance modular systems for high performance measurement systems in the test space. All of this is modular so that they can mix and match the processors that they need, the I/O performance that they need, and ultimately they can solve virtually any application from general measurement, test applications, monitoring of large machinery, industrial applications, control applications, and so forth. So let me show you a really cool success story based on this platform-based approach. This is revolutionary technology in the wireless communication space. I've got a video here I'll talk about. They are revolutionizing the last mile connectivity. It's a massive system, 96 antennas, 6 billion operations per second to deliver state-of-the-art communications from a base station to a rural area. 24 client streams. They're prototyping this 24 simultaneous video streams at 71 bits per second per hertz. That's about 100 times the maximum bandwidth of the fastest cell phone networks that are available today. And they're really going to change the way some people can access technology and the internet. So who is this company that is revolutionizing rural communications and bringing broadband internet into their homes? Any ideas? Close. Facebook, right? Facebook is a social media company. So how do they become a revolutionary in broadband communications? It's by leveraging a platform-based approach, and they're happening to leverage ours. Most of the equipment that you saw there is part of our hardware-based platform. They're using our software to simulate these signals, and they're getting tremendous results from that approach. So here's a little bit more detail about our platform, and I'm going to try to go through all the elements of a platform that I said that was continually evolving, an open and vibrant ecosystem, and delivering massive value. So here's a little bit more about our platform. This is a system diagram, if you will, of our platform. Again, at the center is a productive development software in the form of LabVIEW, and then surrounding it are all the pieces that people need to develop real-world systems that deal with real-world signals, right? Hardware for doing acquisition and control, so you can stimulate or acquire any signal that you want in the system. You need to have synchronization, because we don't deal in the world of a single system. Our systems have to talk with many different things and synchronize themselves to the world, as well as high-speed data transfers to grab all this data and send it back to the latest and greatest processors on the planet, perform analysis on those measurements, present them back to the user and operator interfaces, and then having open connectivity, wireless internet communications, back to the real world so they can share this data. These are the elements that make up a real world embedded or test system. And our customers use software to mix and match them however they please. I've already talked about how Moore's Law is disrupting the microprocessor space, the semiconductor space. So in this modular approach, as a new processor comes from Intel, you just take out the old controller and you put it into the new one. When our competitors are developing point solutions or box-based solutions, that option simply isn't available to our customers. The same Moore's Law that's going on in the digital domain is also going on in the analog domain. So the main chip suppliers in the space, Analog Devices, Texas Instruments, you name them all, they're experiencing the same phenomena of Moore's Law. And they're developing the latest and greatest analog to digital and digital to analog converters. And what we do is we make them available to the ecosystem by simply putting them in a module that users can use to perform whatever measurement or interact with any real-world signal that they want. In addition to that, it's about the ecosystem, right? These are easy examples to go to here, but I think the most popular and easily identifiable ecosystems in the world are Apple iOS with their App Store and the Google App Store as well. They have over 2 million apps apiece, with more than 1,000 being created every day. You can only have this type of ecosystem if you've abstracted away the hardware of the system with software and allowed open interfaces in which there's a level playing field for everyone to add value to that system. In fact, the value that's being derived out of this is enormous. Apple, with their App Store, made $10 billion in revenue last year alone. It's amazing. We have the same approach. We abstract away the hardware through software. With our LabVIEW Tools Network, we don't have millions of apps. We have hundreds of apps, but you can see that it's a little bit different. It's different when you're dealing with engineers and scientists as opposed to the commercial space that Google and Android deal with. And so this is important, right? But what's really important in our ecosystem is all the people that interact with each other, the community that's created, the 300,000 online users that support each other, that add code back to the ecosystem, that collaborate with each other. It's the 8,000 different universities that are using this platform for cutting-edge research and supplying that research back to the ecosystem. And it's over 1,000 alliance partners working to create those systems and help our customers be successful. And to put that value into perspective, I'm pretty proud of the role I play at my company leading our R&D department. We have the largest investment of any of our competitors in the spaces we serve. In fact, we have 40% more engineers working to solve and create this best-class platform than our leading competitor does. Right? And I'm pretty proud of that. I like it. And our competitor might be able to think he could out-invest me in the future if he did things right or made the right sacrifices. But the truth is my ecosystem is more than 100 times larger than my investment in R&D. And because I've developed my R&D in a way that's open and flexible for everyone to use, they actually add value to my value. They amplify the efforts that I have. Since my competitors have chosen a closed approach, right? They can't have this value, and while they think they could maybe invest at the same level that I do, they cannot out-invest my ecosystem. And that's an incredible advantage that I have. It's something that you should consider when you're developing the systems that you create or leveraging systems as you go forward. And then there's about the massive value. Here's a quote from William Gibson: "The future is already here, it's just not evenly distributed. It's in the hands of the people that know how to access this technology the correct way." And one of the really great joys of my job leading the R&D department at National Instruments is that I get a front row seat at the future that our partners and our customers are creating. And so what I'm going to go do next is just go through several different examples, wide variety of application spaces, and the massive value that's created by the use of leveraging an open platform. They're all using the same software, they're all using the same hardware. So start off with the largest machine in the world. It's the Large Hadron Collider in CERN, right? They needed a flexible system to control the beam of electrons that's going around that beam. They turned to us with LabVIEW, hardware that they could deploy to FPGA technologies, and the right I/O to control those beams and make sure that they don't run off course. Now, what's really powerful, that statement of reducing that barrier to entry, the people that designed this thing, they knew how the theory worked, they knew where they wanted the electron beam to go, but they were not system designers of embedded systems and FPGA programmers. And our platform lifted them up to the point where they could do that on their own without special assistance. It was amazing, it's exciting, and we all know about the news that we've heard about the discovery of the Higgs boson, the God particle, and so on, what that all means for us as a society. That exact same technology, in a much smaller form factor, is used in cancer treatment, right? So that's a pretty close example. You're going, hey Scott, that's not that much different in medical, because it's basically a nuclear accelerator, just a smaller version of what was going on at CERN. But another one in the medical space, and I'm going to hit a couple in the medical space here, is this cell frame technology, right? This is a really cool example. Esophageal cancers, right? If you have to have if your esophagus is so damaged by the cancer and you have to have it removed, it's a pretty terrible therapy. They have to take your stomach apart and literally create a new esophagus and attach it to your mouth. Your quality of life is terrible. What they're doing here is they're taking cell tissue from your own body and using the exact same software that I talked about in the Large Hadron Collider with our C-RIO embedded controllers and FPGA technology to grow new esophaguses. Right now they haven't planted them in humans yet, but they're under animal trial. That's really saving the quality of life. And again, this guy who thought up this idea, he was a medical researcher. He wanted to test his idea out, had a new idea, wanted to get it to market. He didn't have to hire a team of embedded developers, system designers. He could leverage this platform and bring his idea to market sooner than he could through then using traditional approaches. Here's another one, impacting the safety of our airports. Everyone remembers the Concorde disaster. It was the result of a small piece of debris being picked up by the airplane as it went by, damaged the airplane. The plane obviously exploded, and it was obviously a tragedy. What our customers are doing is they're taking the exact same approaches and applying them in a different area with a radar type technology where they can detect a 5 centimeter long strip of debris on the runway, any place on the runway. That's equivalent to finding a penny on a football field in the fog. It's pretty amazing stuff that our customers are doing with this exact same software-centric hardware platform. In the industrial space, a company called Flowserve, they are using these exact same tools and approaches to monitor pumps, valves, and various industrial equipment to reduce downtime. In fact, they talk about that through our global industrial processes, there's about 5% waste because of downtime. Through this monitoring process, they have the potential, granted they're not doing this next year, but the potential to save $20 billion in the process by developing better condition monitoring systems with the same platform-based approach. It goes on and on. One of the coolest ones is everyone right now, if you're looking at your phone, it probably says 3G or 4G on it, maybe LTE, the current cellular standards, right? The goal is to multiply the bandwidth of our cell phone systems by 1,000 times. The researchers and scientists that are doing this don't actually know exactly how they're going to do it at this point in time. They know they're going to go up in frequency and get more bandwidth. They know they're going to use techniques like multi-input, multi-output, having hundreds of antennas on your cell phone, hundreds of antennas in this amount of space, in order to increase their bandwidth. And they're going to try really revolutionary modulation schemes to make that happen. But what they need is these guys that are thinking up these ideas, they're scientists that don't have experience developing the actual base station or the actual cell phone. So they need a platform that gives them the ability to test out their algorithms, test out their approaches, and deploy it. And our platform has become the premier platform for wireless research in this space. When it says 5G in the future, you can be pretty confident that those algorithms or the approaches were tested with a National Instruments platform at its heart. And so you can see some of the world's firsts. I'm not going to go into this alphabet soup of acronyms that's over here, but it's pretty cool stuff. One that I would like to highlight is the world record was recently obtained in spectral efficiency. That means, spectral efficiency, that just means cramming lots of stuff in a channel over the air, how much data that can transmit over the air. A world record at 145.6 bits per second per hertz. And that was done by some universities that we work with that were testing out their theories, University of Bristol, University of London, that made that all happen and had made a great things happen. Now, once you take that theory and you need to put it into practice, you need to test it. One of the giants of the cellular space is Qualcomm. They basically make most of the chips that are in your cell phones today. They've used our platform from a test perspective, not from a design perspective, to increase the performance of their test systems by more than 200x. And if you're operating in the test space or you're designing devices, you know that every year things get more and more complex. But you don't get additional time, you don't get additional resource to make that happen. You have to leverage a platform that gives you access to more technologies more efficiently as they come online, and that's what they experienced at Qualcomm. They were not only able to test more protocols that are listed across here, right? They were actually able to see more about the signals that their systems were producing. Pretty incredible. And then here's one a little bit more close to home, right here in Mexico. Adriano Engineering, the founder is Marcos. He's sitting here in the front row. He's a technology entrepreneur that's been leveraging this platform right here in Mexico. He's reducing the cost of test and increasing the quality of electronic systems. And he's doing that at big companies, Whirlpool, Tesla, Mercedes-Benz, General Motors. How long do you think he's been in business doing this? A year and a half. So it was the platform that raised him up and gave him access to these technologies and allowed him to go on and start a business, be an entrepreneur in this space, and drive real value moving forward. It's incredible what can happen at both the gigantic and at the local scale when you leverage a platform. So to wrap things up, it is absolutely an exciting time to be a technology entrepreneur. The world is changing at an exponential pace. Right? It's not really a question of whether or not you're going to need to use a platform. It's what platform are you going to use and what platform are you going to potentially create to do that. If you're working in the measurement and control space, please evaluate our platform. But as a technology entrepreneur, to deal with what's going to happen in the future, you need to be working with platform-based tools, open software, and modular hardware systems to make that happen. So with that in mind, really the only question is, what disruptive innovation are you going to drive moving forward? So, thank you very much.